Van der Waals introduced two corrections in the ideal gas equation to explain the behaviors of real gases. One is pressure correction, the another one is volume correction. Pressure correction we already discussed. In this part we are going to discuss about the volume correction. So, what is volume correction? So, each and every molecule of a real gas occupies certain volume or a definite volume. This volume is not available for the free movement of the other molecule. Therefore, the measured volume is always greater than the ideal volume. So, Van der Waals introduced a volume correction factor in order to get the ideal volume of the gas. The volume correction factor is known as V dash. What is V dash? V dash is the excluded volume. Let us consider a container with the volume of V liters. So, V is the volume of the gas, that is V. V dash is the volume correction, V minus V dash is the ideal volume of the gas, that is V ideal. Then what is V dash? That is excluded volume. What is excluded volume? This is the volume available for the free movement of the molecule, that is equal to volume of the container, that is equal to volume of the gas minus volume correction V dash. So, how to calculate the excluded volume for two molecules? So, this is one molecule, this is another molecule whose radius is r. So, how to calculate the excluded volume for these two molecules? Radius of one molecule is r, the radius of another molecule is r plus r 2r. Now, we draw a circle with the radius of 2r. So, what is the volume of this circle? That is 4 by 3 pi into 2r cube. This is the excluded volume for two molecules. Okay. The excluded volume for two molecules is 8 into 4 by 3 pi r cube, that is taken as 8 Vm. 4 by 3 pi r cube, this is the volume occupied by a single molecule, that is taken as Vm. So, the volume occupied by a single molecule is taken as Vm. So, instead of this we put Vm, therefore, 8 into Vm, that is 8 Vm. So, excluded volume for two molecules is 8 into Vm. What is the excluded volume for a single molecule? It should be divided by 2, that is 8 Vm by 2, which is equal to 4 Vm. It is taken as B. B is a constant and it is known as Van der Waals constant. The value of Van der Waals constant B is equal to 4 into volume occupied by a single molecule. For a single molecule, the excluded volume is B. For n molecules, it is Nb. The excluded volume for single molecule is B. For n molecules, it should be multiplied with n, that is Nb. The value of V dash is equal to Nb. So, substitute the value of V dash in this equation, that is V ideal is equal to V minus Nb. This is the corrected volume. It should be substituted in the ideal gas equation, that is PV is equal to nRT. So, what is the volume V? Corrected volume, that is V minus Nb. What is the corrected pressure, ideal pressure, that we already discussed. The value of ideal pressure is P plus A into N square by V square, that is equal to nRT. This equation is known as Van der Waals equation for n moles. In this equation, A and B are known as Van der Waals constant, depend on nature of the gas. So, this equation is used to explain the behaviors of real gases.